Hello. Now we will be having the Q&A session of our previous lecture, Linting rules for FPGA design and verification. So 6th of, or in total 30 in English FPGA from 0 to hero classes. So could one of you please tell me about the video quality and sound quality? Is everything all right? In the meantime, I am setting up our Discord voice channel in case you have some verbal questions. Please join our False Pets English voice channel and ask your questions verbally. It is preferred. Everyone will be hearing your voice, so it will be informative not only for you but also the listeners. So let me join the voice channel. I need to set up one thing. Just a second. Yes. Yes, everything's fine. I think you have heard the clap sound. Yes, I am online and right now like 3+. Yeah, only 5 people are online. Right now, normally it is like more than 30 or something, but since the Discord is restricted in Turkey right now, and for now majority like 70% of the watchers this series are Turkish. I am also Turkish, so since we made 30 classes in Turkish, so yeah, some students and 0 to 5 year engineers, FPGA engineers are aware of these in English classes as well. So yeah, majority is still like that, but yeah, in total each video is watched from by 1,000 people in a few weeks. So yeah, in my opinion, attending classes online and asking verbal and text questions, it will have the best impact for you. You will memorize those, learn more. But of course, some people prefer to watch during their spare time with some different speeds, for instance 1.5x speed, etc. So it depends on your preferences and availability of your schedule. I think we are good. In case you ask something verbally, I will be hearing. Let me also hear the clap voice from my speakers as well. Yes, we are good. So let me check. Thanks, Furkan. Furkan is like our gatekeeper nowadays, so he is answering clean and clear. Thanks a lot, Furkan. Because people are working and it is like getting late in Turkey. So thanks for joining online classes and approving that video and sound quality are fine. Thanks a lot. So okay, by the way, if no one asks any question, I will review the class much faster compared to the 5th lecture. I will make some general comments, and if there is not any question, then I will end the stream. So let's hope there are some, but in case there are no questions, I will end the stream for the Q&A session today. By the way, I prefer, I will prioritize the linting rules for FPGA design and verification questions. But in case you have some other questions, don't hesitate to ask them as well. So if answers are short and precise, I will explain. If that I am not expert related to that question, or the answer is long, then I will try to provide you some links, some reference documents, etc., or some of my ex or current colleagues that know much more about that specific topic. So you may ask any questions you would like to. Hi again, Barış. Hello. So let's see. Yeah, by the way, this is the same presentation. I just made a few corrections we discussed during the previous lecture, the 5th one. So yes, this is the Q&A of HDL linting rules. So agenda is just the reviewing those rules fast and getting some questions related to that, but also other questions are appreciated. Yes, I know. I just mentioned a few minutes ago, Barış. Normally, yeah, I made these classes in Turkish as well. You probably know there are 30 classes, and even late Wednesdays, there were like 30, 40 people online, and right now only 5 people are available on Discord. By the way, I am in the voice channel. Yeah, since I am not living in Turkey right now, so I don't have any restrictions or bans, but you may try to ask your questions from the YouTube chat right now. Also, I mentioned if you have other questions not related to these linting rules, also I will try to answer them. What is TeamSpeak, by the way? Is it Teams or another program? By the way, I don't want to switch to another other environments, other tools, because others may be banned as well, prohibited as well. So yeah, I don't want to waste time with that. So just if you have some questions, send them to me through LinkedIn direct messages, for instance, or email them to me. I have the email address on the description of our YouTube channel, False Pets. So yeah, because if I switch to another one, that one might be prohibited as well, banned as well. So I don't want to waste time with that stuff. So I am really against that banning, but proper education shall make people not to use that bad tools, bad programs, or good tools in a bad way. So I won't waste my time to switch to any other environment right now. because I'm already working 8 hours during weekdays, and I am doing these classes extra, and it is already tiring. So I won't change, create different servers, different text channels, different voice channels for each and every program. So I will stay in Discord for now. So, but if it becomes, if we have the same issue after 4 weeks or something, if it is that that restriction is not cancelled, maybe we will discuss. Let's see. But for now, please use LinkedIn, email, or YouTube chat box. Okay, we have a question from Furkan. Just a second. Okay, like waiting power up time of the sensors that are used in the system, we wait the power up from time of that IC for only once. Should we separate this waiting time and control this with a flag? Okay, let me try to understand it better. Like waiting power up time of the sensors that are used in the system. Okay. There is a power up time. So sometimes, by the way, they have multiple power pools, like 3.3 volt, 2.5, 1.8, 1.2. So you need to be sure each and every of them are stable, and those ICs are power up in a correct way. So question is, we wait the power up time of IC for only once. Okay, after the power up, you wait for that power up time. But I think you are not mentioning here the FPGA one. You are mentioning more like the sensors or actuators power up time. Okay, anyways, let's continue. Should we wait? Should we separate this waiting time? What do you mean by separating this waiting time? I couldn't understand that very well. And control this with a flag. Controlling this with a flag, it's 100% fine, but I couldn't understand very well what do you mean by separating this waiting time. Separating which waiting times, for instance? Separating it with what? Are you mentioning those sensors, actuators, maybe other AICs, like ASICs or hard CPUs or GPUs? So yeah, I couldn't understand very well the separating this waiting time. Maybe you shall use another verb so that I can understand. Or just type it in Turkish. I will translate it on the fly. Just try to explain it again. If I cannot understand, I will inform you. Please write in Turkish then. In the meantime, I will read Barış, question of Barış. You mentioned about how the architecture defined and then broken into smaller parts. Okay. I want to know how it works on embedded software side. Do you have any knowledge about that? Yeah, of course. Okay, let me since the question of Barış is more clear to me. Let me answer his question first. So actually, embedded software, yeah, I didn't do embedded software design that worked or still working on that projects, many great projects that I worked, but I have written some test code to check the sometimes object oriented, sometimes usually not, but sometimes object oriented C++, Python stuff to check the behavior of shared ICs like memories, DDR3s, DDR4s, Also check the behavior of the soft cores. So yeah, I have some knowledge. Also, I got nice Python and C++ trainings. So object-oriented coding trainings in the past. So the answer is, of course, you are doing similar stuff. You are writing some tasks. Actually, you are benefiting from those great features of object-oriented languages. What are those? Those like encapsulation, like those base class and parent class, child class relations. But let me Google it. I will also, of course, there are 4 or 5 major features of object-oriented programming languages. So let me try write OOP, object-oriented programming, best, let's say best features. Mastering OOP, a comprehensive guide. I got that one. Let's check. Probably you are since you are asking this question, you are a software, embedded software or software guy. Software, so don't hesitate to type them as well. I can read directly, but let's see what those were. Okay, encapsulation. So inheritance, that starting from a base class and then getting some derived classes, those parent relationship, etc. And abstraction and polymorphism. I think there are 4, right? These 4 stuff. So these are by using these great features, actually those hardware description languages, except SystemVerilog doesn't have. By the way, SystemVerilog has that object-oriented features, but they are not understood by EDA tools like Vivado, Quartus, and Libero, and transferred into FPGA resources directly. So SystemVerilog object-oriented part is 99% for verification. So in general, okay, VHDL, the design commands of hardware description languages, that you can do many things. You can realize really complex algorithms, but they are not directly, as you may know, they are not, of course, object-oriented. But coming back to your question again, you are, of course, doing that stuff in embedded software as well, because when it is embedded, you have, compared to a software program, you have much less resources. Like you don't have those extremely fast AMD or Intel CPUs, also that crazy GPUs on your racks or on your desktop PCs. So when it is embedded, you have less resources. They shall be more optimized, sometimes real time to some extent, like in CPUs. Also, there are, real time CPUs. Yeah, they can do some good job on real time processing. So yeah, each type of those ICs have some pros and cons, of course. That is why all of them are still on the market, and some people are benefiting from them. So some people purchase them. But at the end, of course, you are benefiting from, when it is embedded software, actually you are benefiting from that 4 great features of object-oriented languages, and you are doing the same stuff. So you write some optimum functions, optimum tasks, you reuse them to some extent, and you solve problems by divide and conquer at the end. Of course, sometimes it makes more sense to combine some solutions. So I cannot say all the time that divide and conquer prevails. It is not like that. But majority of the time, as long as you have some optimized functions, optimized solutions, optimized reusable tasks, which achieves the embedded software problems in a shortest time possible by using as least resources as possible, then that is much more valuable in embedded systems. That is the point. Okay, Barış has some more questions, but let me continue with now Furkan's question. Let's check. Okay, he added some. The question is separated because of other messages, by the way. The question is separated because of other messages. If you check previous messages, full question is above. Aha, okay. There is another, okay, I missed that part. Okay, good to mention, Furkan. I had a question, okay, I had a question about separating arithmetic counting operations from our FSM processes. Okay, good. By the way, we will be discussing that in detail during our good coding practice classes. 2 or 3 weeks it will be. I couldn't remember. By the way, let me check. It is here. We have 3 good coding practices starting from 5th week. This is the week, 3rd week. So course 5 and 6 we are having. So 2 weeks later, 4th week, we will have Git, Bitbucket, Jira, and CI/CD pipelines. Then we will have 3 good coding practices and design recommendations. For that one, for FSM, separating arithmetic counting, arithmetic operations, or those output functions, math functions, and the state change part of FSM design. We will have some examples on the whiteboard. So because recently some more people asked regarding that and I answered, but we will be having that during our good coding practices and design recommendations classes in more detail. But let me read the remaining part. From our, okay, should we separate counting operations from our main process even if the operation is done once after the power up? Yeah, yeah. Even if it is done once, sometimes you may need to do that because it depends. Actually, it depends on your clock speed, Furkan. Even if you are doing it once, if you are doing it, for instance, at 500 megahertz and you have only 2 nanoseconds to process that signals, inputs or internal signals, then you shall separate it. So it depends on your clock speed, on your design requirements, so many things. So even if it is once, by the way, synthesis tool doesn't check any operations depending on the number of times you are doing it after the power up. Tools are checking if it is possible to do that synchronous, let me say, sampling in 1/, your clock speed time. Let's say it is 500, then 2 nanoseconds you have. So you need to have those combinatorial delays, pet delays, and some that lookup table stuff, decisions, and setup and hold time. So they calculate. If it is, by the way, if it is fully synchronous, so without any asynchronous reset, tools check setup and hold time. If you also have an asynchronous reset with asynchronous assertion, synchronous deassertion, it also checks recovery and removal times. So slacks shall be positive. So it does, even if it is once, you shall not have any negative slacks. So of course, if it is once, you may do some extra optimizations. You may combine some different processes, or if your clock speed is low and if requirements are not that tough, then you may do it in the same process as well. So the repetition time of the how many times you are doing, and a signal sampling, a decision, sampling a signal and outputting the result after that TCO time, clock to output time. It doesn't have direct relation with how many times you are having. The importance is you shall have positive slack for the whole static timing analysis. Yeah, if I think I made myself clear. Also, we will be discussing that stuff more in detail with some more precise example. Even I will prepare better examples compared to Turkish lecture, because yeah, we had that FSM lecture and actually we went through 15 rules, but like 3 of them, all the majority of the people that watched these classes, they asked for some examples, so I will be providing those examples. So either during the Wednesday classes or Sunday Q&A sessions, we will went through them either on Notepad++ or the whiteboard behind me. Okay, nice one. If you're not satisfied with the result answer, please let me know. But for this one, I think I explained enough. We shall discuss further after the class if you want, using LinkedIn or email, or yes, if you can access through the Discord. Okay, I answered the first part, first question of Barış. Second one, I'm a junior embedded software developer. Great. My current job is related to Zinc SoC and RTOS. Nice. Real-time operating systems. Yeah, they are quite on fire, those. Yeah, they are quite, let me say, popular, because using SoCs, you are providing hybrid solutions benefiting from hard IPs of SoCs, hard CPUs, sometimes like multiple processors like Xilinx UltraScale plus MP SoCs. Also, yeah, they have a real-time CPU there, plus you may run some embedded operating systems, real-time operating systems, RTOS ones. So they are, since those, especially Zinc ones, are a little bit old nowadays, but if you are using, for instance, Versal chips, Agilex 7 chips, which has roughly 7 nanometer technology, they are quite fast, and they have newest AI optimized artificial ASIC parts, scalar and vectoral IPs that are capable of doing artificial intelligence related operations really fast as well. So that latest SoCs are like a combination of great FPGAs, hard CPUs, and GPUs. So they are quite nice to make to realize complicated, really valuable algorithms. So of course Zinc is also great because it has like 20 nanometer as far as I remember, or 20 nanometer or 28 nanometer technology. They have like Zinc have like Vertex 7, RTX 7 or Kintex 7 FPGA architecture depending on the family. So they are quite fast, relatively fast, let me say, because there are also like 40 nanometer, 80 nanometer RAM based or flash based technologies as well. By the way, making, just as an extra information, uh, flash based are FPGAs are in general slower, but they have some other features. For instance, they don't require flash based FPGAs like microchip ones. Also, like Max Time family of Intel, let's say, they don't require an external flash to uh, on to keep the bit stream. So they are flash based. You just load your programming file, and you don't need to load the bit stream from an external flash. Also, they are more secure. Yeah, they are more immune to radiation, etc. So all the chips like flash based one, they were calling previously CPLDs, complex programmable logic devices, but yeah, flash based ones in the past when Actel, the name of that company was Actel, but then they renamed all of them as nowadays as FPGAs. Even if they add also hard CPUs, they call it SoCs. So also microchip has some SoCs. But tricky part is what I was going to mention. Yes, making, you can, it will be cruel. It will not be, let me say, objective to compare nanometer technology of flash based and RAM based FPGAs. So flash based are, yeah, because of their technology, their transistor uh, sizes are bigger, flash based one, but they have some other features like I mentioned in a few minutes or seconds ago. Okay, so also I programmed PL side of SoC in university, but not advanced one, like Pong game on VGA monitor. Nice. Where is the question? I also made simple high-level block designs. Good. Currently looking for a job abroad. What do you suggest? Should I go embedded software side or digital design? I really love all of them. Digital design. Yes, actually knowing both is quite valuable. So you can, for instance, for your case, I strongly recommend you to buy a SoC, cheapest one possible. Just check the prices on the web, etc. So if you buy a, for instance, Ultra 96 development kit, which is a not Zinc, but it is better ultra scale MP SoC plus. By the way, it's Europe prices, US prices like 250 US dollars or something like that. So they are not that expensive. But yeah, due to custom additional taxes from Turkish custom, so it is little bit more expensive, up to sometimes 2 times more expensive. But check, sometimes there are nice campaigns, nice discounts. So try to, if it is possible, of course, at work, try to use those SoCs so that you will improve both your PL, programmable logic, and PS, programmable software side. But if you are supposed to do only embedded software embedded software tasks at work, then I recommend you to buy a SoC and SoC such that you will improve yourself in both sides. But please remind this, in huge companies, the biggest ones, like the well-known ones, usually you are supposed to have expertise in one of them, either in embedded software or FPGA design, digital design. So yeah, majority of companies, yeah, according to my observations, after 15 years, during those years, yeah, for instance, you are either a FPGA designer or FPGA verification engineer or embedded software designer. So kind of. Or sometimes, you know, you are also, there are embedded software testers. So they design some unit tests and try to test and improve the quality of the embedded software design. So to be honest, most of the time you need to your tasks, majority of your tasks, let me say, will be in such companies, either of these specific disciplines. So it is not like one guy is doing embedded software, even, you know, embedded software, there are, for instance, real-time CPU, some also those different cores of CPU. Sometimes, let's say, there are 6 cores or 10 cores or 16 cores. Sometimes even those cores are distributed among the available software engineers. So it is a little bit, you know, also different algorithms, different requirements are sometimes solved by engineers from different expertise levels. So yeah, in my opinion, both are quite valuable. When we are coming back to your question, so I would buy a SoC, and okay, if you cannot buy now, save some money for it, and at some point of your career, buy an SoC to improve yourself both in embedded software and embedded hardware or firmware, let me say, PLPS stuff. You know those terms because you are working on Zinc. But remind, yeah, know that usually you need to have some expertise on those specific disciplines. Then microelectronics embedded software. Okay, I think I got that. By the way, also I consider master program about microelectronics. How it may impact my career. Which one is easiest way to went abroad for a job? Master of Science, then job, or directly job? Yeah, it depends a little bit. For instance, it depends your expertise as well. But let me answer it from a FPGA designer or FPGA design verification engineer. Yeah, by the way, it depends on how many years of experience you have as well. But having Master of Science in Turkey will be a big plus, because some of those job offers, they require Master of Science, and even if it is not a must, if yeah, they may prefer the one having Master of Science. So but also, if you can get a good scholarship from a European university, or if your family has that purchasing power to make you, to help you study there without any scholarship. Having Master of Science in Europe is quite valuable as well, because you're in the meantime, when you're students, you're getting used to that culture, you're learning their languages, which one they are speaking, and there are great universities in Europe. Yeah, they don't have that many universities as we have, but they have the quality. So it depends on your options, it depends on your expertise, many things. But uh, yeah, also it depends on your current job, if you are paid well, and if they permit you to have a Master of Science, uh, then you may prefer that one as well. Yeah, but if you would like to go abroad as soon as possible, and if you have that purchasing power, then I would tell you to have the Master of Science or PhD in Europe, because compared to like Hacettepe, like Middle East Technical University, like Boğaziçi, that's Master of Science and PhD is easier in Europe. So their curriculums are easier. They have many technical visitings. So technical, what do you call it in English? Technical, let me say, events. They are visiting some universities, visiting some companies. So that's thesis are not that tough compared to, yeah, I had my Master of Science, for instance, in ODTÜ, Electrical and Electronics Department, with a great academician. Actually, he was at that time assistant professor, Ali Özgür Yılmaz. Right now he's professor in METÜ, ODTÜ, Electrical and Electronics Department. Yeah, but that thesis, yeah, by the way, working and having your Master of Science together, it is not easy. Also, yeah, that I think, according to my experience, according to my observations, yeah, it is much easier to have Master of Science and PhD in Europe. Also, there was another pro. You can do it in a shorter time, especially when it comes to PhD. But there was one more big plus. What was it? Just a second. Yeah, they can do it in a shorter time. There was one more pro to having. Yeah, by the way, you are getting also, if you are doing your Master of Science in Europe, you are getting some network, social network, professional network, and it is much easier to be accepted by different companies in Europe or United States or any other countries. So it has some big pluses, but as I mentioned, it depends your purchasing power, the money in your pocket. Let me say, no, in a more clear sense way. Let me say. So it depends on many factors. But if you can do it, if you can apply and start, just do it, in my opinion. Okay. You can ask further through direct messages, Barış. I think, yeah, they are not that unrelated. They are fine. But we had, I think we answered most of your questions. Furkan said, thanks a lot. Yeah, thank you both, Furkan and Barış, for nice questions. One more question from Barış. I also want to know how it is your development environment, what kind of tool chains you use, which operating system do you use, Linux or Windows, with virtual machines. We don't use, yeah. By the way, I recommend you to check Turkish classes, because I mentioned them. We discussed those in detail. Also, I will, as during the next lecture, next lectures, remaining ones, we will have 24 more. So I will mention them, but as a fast answer, for the laptop I am using, it is Windows, but all those development environments are Linux based. So CI/CD, continuous integration, continuous deployment, regression environments are quite good. They are Makefile based, they are Tickle based. There are some custom Python solutions as well. So let me say everything is on Linux servers, and also there is a great, at ASML to be specific, there is a great electronic computer aided design ECAD support. 10 experienced engineers. For instance, one of them, actually leader of them, had his Bachelor of Science in uh, Middle East Technical University, my university, electrical and electronics engineering department as well. So they are doing really good job, like IT, but they are more specific to electronic computer aided design tools. So they are updating all those development environments. It is much more professional compared to other two companies I worked in the past. So yeah, they are really optimized. So almost everything are running in batch mode. You are opening graphical user and interfaces of design or simulation tools when it is necessary. So you are not wasting your time. So design cycle are much faster. Also agile methodologies are used. So like 3 week sprints, design tasks are clarified very well, and yeah, documentation is really good. Yeah, these speed up all those complex design process, and quality factor of the design is really good. By the way, majority of the companies are trying to achieve this, of course depending on the resources they have, depending on their priorities, depending on their budgets, it may differ, but ultimate goal is having, of course, by the way, those environments or everything is not perfect at ASML as well, but the intention is good. They try to improve, they collect some feedback and take some actions accordingly. So that is the that shall be the approach for any design cycle of any discipline, any engineering, let me say, sub-discipline or discipline. Nice, you have ultra scale MPOCC already. Then do yes, I think it is much better to study in European Union. I agree. Also, there are really nice universities in Sweden, Switzerland. EPFL is there. It is really great university. Also in Norway, there is, for instance, in Trondheim, there is NTNU, a Norwegian Technical University and Applied Sciences. So one of my alumni and close friends and ex-colleague also from Aselsan, he had his PhD there. That university is great. So check all different countries, universities in Europe. Yeah, like majority of them are really good, really great. And by the way, I was going to mention, I forgot a few minutes ago, but those they are easier according to, not, this is not only my opinion, this is opinion of many ODTÜ, Hacettepe, Bilkent, Boğaziçi graduates. They are easier. Also, their rankings are better, world rankings, because they invest their those governments, those states invest a lot of money. So they spend a lot of money. They have great laboratories. So like more freedom in universities, and then their rankings are better because they release really the outputs are really good, because we have great students and academic personals in Turkey as well, but we are lacking to have some budget sometimes, because I hear that, for instance, students from ODTÜ, İTÜ, Boğaziçi, they say they were going to do some great ASIC stuff, great FPGA stuff, great SoC stuff, but their professor or assistant professor or academic personnel, they couldn't get the budget. So we have such issues. But in Europe, yeah, those countries are richer, and they have, let me say, relatively better standards. Of course, not all of them, also not in all subdisciplines, but for FPGA design, electronic design, like microelectronics you mentioned, just Google them, search them. There are great opportunities in EU, European Union, or US. So just search for it, talk with some people, like ask questions to other people like you did to me. I think you already know, because your purpose is, your aim is to do that as well. But you are right. So I would say that is the correct intention and motivation. Yes, of course, but yeah, but all I saw that wow, it is amazing to provide that kind of support. I want to work there. Yeah, it is great, I would say, but also this company has some drawbacks as well. Yeah, there is no like perfect environment, but yeah, it is correct that like Apple, like Samsung, like ASML, they are #1 in the world in terms of their expertise, so they provide really good standards. So yeah, by the way, work like this, keep this motivation and discipline. You will be working one of those companies soon. Great to hear that you are also a graduate from Hacettepe Electrical and Electronics Department and working on TÜBİTAK. Yeah, they are great. Both are great. I have many colleagues from Hacettepe EE, so they are, yeah, like you. They are quite smart. Yeah, I think best 2 of 3 best FPGA engineers I know are from Hacettepe EE. So yeah, you are lucky in that sense. Yeah, you have a great university, great department. So, but it is tough. You know, it is tough. So, if you are also from that, like ODTÜ, Hacettepe, Boğaziçi, just have, and if you are eager to have your Master of Science or PhD, I recommend you to have it in EU, so that with less effort, you will get a Master of Science, and you will learn a lot. You will benefit from the nice standards in European universities. That would be a nice one, because you're already a graduate of one of best universities in Turkey. So it would be nice chance to, nice alternative to have other one in somewhere else. No, it is still, those are still great, but such things happens, you know, that politics is ugly everywhere. So don't think like that. Those universities are still great. So just focus on your targets, focus on your motivation, and try to learn and be a better engineer in the field as soon as possible. Just focus on the positive things. Okay, great. I think we had a nice Q&A session. It has been, I think, 1 hour or something like that. Let me check how many minutes. Okay, 65 minutes already. Nice. I think we are good. So we will be seeing each other on the 16th of October. And our topic will be, by the way, Barış, I will give examples during the next classes because it is Git, Bitbucket, Jira, and CI/CD pipelines. So Git is, you know, the version management tool. Bitbucket is CI/CD tool. Jira is the task management tool. So yeah, regarding the question you have asked, I will give some more detailed examples about using, benefiting from these tools with regression, during regressions, during qualifications, and during system integrations. So yeah, this automated continuous delivery environments help you a lot in terms of giving a high quality, bug free, as much as possible bug free uh, FPGA or SoC designs. So we will be talking regarding that on the 16th of October. Thanks a lot, everyone, for listening now or later offline. And special thanks to Barış and Furkan for their nice questions. Hope to see you next week. Bye bye. Have a nice. Now it is not only in Europe but also in Turkey. It is night. So good night. Bye bye.